Hello there, this is question MM092 of the Maths Methods Sharpened Study Guide. Solve the equation 5e to the power of t plus 4e to the power of negative t equals 9 for t. If you haven't seen a question like this before, I can understand how confusing it might look because the first step is the hardest step to take with this, and then the rest becomes quite simple after that. So let's rewrite the equation. 5et plus 4e negative t equals 9. Cool. So this is very similar to a exponential question where you change everything to a quadratic. It's almost exactly the same, but it looks different because there's a negative t here. So firstly, we actually need to times everything, both sides, by e to the power of t, and you'll see why in a second. So if we times both sides by that, it's fine. We can do whatever we want to both sides as long as we're doing the same thing on each side. So this becomes 5e to the power of t squared, because it's e to the power of t times e to the power of t, plus 4e to the power of negative t times e to the power of t equals 9e to the power of t. So this e to the power of negative t and e to the power of t, that becomes e to the power of negative t plus t, which becomes e to the power of 0, which becomes a 1. So you then get 5e to the power of t squared plus 4 times 1, it's just 4, equals 9e to the power of t. If we get everything on one side, we get 5e to the power of t squared, take away 9e t plus 4 equals 0. So what's our next step? We have to let e to the power of t equal a, because as you can see, this is actually a quadratic. Now what we get is we get a cross multiplication 5a, negative 4 and negative 1, which gives us 5a take 4 and a take 1 equals 0. And what we get is a equals 4 over 5 and a equals 1. And what does a equal? E to the power of t. So e to the power of t equals 4 on 5 and e to the power of t equals 1. So therefore, log e of 4 on 5 equals t, and log e of 1 equals t, which means that t equals log e on 4 or 5, and log e of 1 equals 0, because that's a log rule. So therefore we get t equals 0. So our two answers are t equals log e of 4 on 5 and t equals 0. Now let's make sure that that actually works with the question that's given to us. So we get solve the equation 5et plus 4e negative t equals 9 for t. We're not told that t can't equal 0. We're not told any of that sort of stuff, which means that we have two answers for t, log e of 4 on 5 and t equals 0. Now just looking at part B, we've got solve the equation log 3 of 5 take 2x, take log 3 of 2 take 3x equals 1 for x, where x is less than 2 on 3. So this is not actually relevant to question A. This is a very similar style of question in terms of the A-B structure in exam 1 for maybe the second or third question, or maybe even the first. So yeah, this is just a log equation. So we've got log 3 of 5 take 2x minus log 3 of 2 take 3x equals 1. And like I've said previously, what we want to do is get a log on each side so that we can make everything equal each other. So if we've got a minus in between two logs and there's no coefficient in front of the log, we can apply our division rule, which means that we can merge the two logs and do the first bracket divided by the second bracket, and that equals 1. Now, like I've mentioned before, there's two ways to do this. We could do 3 to the power of 1 equals this bracket, according to our exponential law, or we could convert this into a log and then make the brackets equal each other. I personally like doing the exponential way. So I like saying 3 to the power of 1 is equal to 5 take 2x over 2 take 3x. 3 to the power of 1 is simply 3, which means that when we times both sides by 2 take 3x, we get 3 times 2 take 3x equals 5 take 2x. So from here, we actually get 6 take 9x equals 5 take 2x. And getting everything on both sides, plus 9x to both sides, we get 7x on this side. And taking away 5 from both sides, we get 1 here, which means that x is equal to 1 over 7. Now, does this actually work in the context of this question? It tells us that this is the equation where x is less than 2 on 3. Now, is 1 on 7 less than 2 on 3? Yes, it is. So that's a perfectly fine answer. We have 2 marks in this question. Last mark is always the answer, and the first mark is this section here. So there's a lot of room for error in here, but if you just remember your log laws and how that all works together, these are really, really simple marks to get if you're confident with this. So if you can try and get confident, do that.